Hey guys, today I'm gonna talk to you about my next project or something I guess that I built like a couple years ago. This, what you see, is a wooden 6x6 that's RC controlled, like radio controlled. Just this. Now that the sun came out and got brighter, you can see maybe like if anyone recognizes what these are from. These are from those 12-volt plastic ride-on toys for like kids. That are like they're all basically each wheel has like its separate motor. They're all fully plastic. I mean, it's terrible for driving on like gravel or asphalt, but in the grass it grips, or like in the like mud or whatever. And you can see this is all made out of like lumber, all like 2x8s, 2x6s, plywood. I just love my wood, my woodworking skills. The lights are just basically under cabinet lights. That I just basically like what? I just put a fan grill over it. And yeah, just to like, so the armored lights, so like when I hit something I don't break them. Same with the back ones, but the back lights I took them apart so I could just put like a piece of like red duct tape in it to actually make like a red lamp to make the rear lights. Why? I don't know, because it's cool. Now this is the cool part. I'll show you like the inside of it. This thing opens kind of like a grand piano. You got this aluminum stand thing that just folds out, holds it in place. Looks something like that. This is like the whole like inside of it, like all the electrical work I had to do to actually make this thing operable. As you can see, I was like talking about these like motors. These are all from like ride-on toy motors. That's a pretty cool project, honestly, but the only thing that sucked is like these motors are all from different vehicles. Like say for example, the back wheels are from a Hummer, like a toy Hummer. The center wheels are from a tractor of some sort, and the third wheels in the front are from like, I don't know, some pickup truck or God knows what. And like it, like, you know, just really have to like play around and try to install this. And like I could see like this gear motor sticks up more, that one doesn't. Like it's lots of playing around. It's like really finicky to do, but it was doable. And then also, so these wheels all have to be pressing against the ground evenly. Now basically what I'm gonna do is I'm gonna give a rundown on how this works. So first let's talk about the batteries. We have one battery here that's a 12-volt 20 ampere hour battery. This guy's for the control circuit, for like the coils and like the contactor coils, the lights, and like the cooling fans and the electronic controller, which are protected by these fuses. You can see the bus bar, that's a positive bus bar, that one's a negative. The other battery bank here is actually for the motor circuit. So you got like 50 amps. You got like a 50 amp main breaker here that protects one whole side, and a 50 amp for the other side. This thing drives like a tank, so it steers like a tank. That's why I need like that big capacity of batteries, because this is like total would be like 100 amp like circuit you need to actually run this, just because this is all 12 volts, and it's because that's stupidly low voltage. You need like a big current. If this is like say 48 volts DC, I wouldn't need that much, such thick wiring. This is all like number 8 gauge wiring I got from like a stove cable. I just stripped like an 8-3 stove cable. I just crimped all this together. Yeah, and so we got the inside this box. You have like the actual controller, or the receiver, or the electronic circuit board that wirelessly controls like the contactors and everything. And the way this electronic circuit board works, it has to like control a bunch of relays that I employed for this task, because that little circuit board is like a small 6-volt like a circuit board that controls like a little DC motor from like say an RC car. That's like a little kiddie car you can buy at the dollar store, that has those little motors that need like 6 volts, like a couple hundred milliamps. Like they're small tiny motors, nothing like, you know, compared to these. So what I had to do is, the way this works is like, so you got like, when I press the forward button, like the polarity runs one way. Say, assume you got two wires, you got blue and yellow wires on the controller. You press the one side, blue becomes positive, yellow negative. You press reverse, it just reverses, so yellow becomes positive, blue is negative. And the way this works is like, this would just be simple to connect a small DC motor, but due to the fact of the power issues, I had to go through relays. So what basically I did was I installed two PCB relays inside this little printed circuit board mount relays that have two diodes. I mean, like, so one relay has one diode in series, the other one has another diode in series. And they're basically, one diode is forward biased, the other one's reverse biased. So if you reverse the polarity, like, the other relay turns on. So like relay 1 turns on when I press this, relay 2 turns on when I press that. And these relays go through like all this wire, like through this wiring. This is like a Molex connector if I want to like service it. So I want to take this whole thing off. I just unplug that Molex connector, I can unscrew this. And then like, so you got like and here's like a terminal block, and that's like, so basically like, so you got like two wires coming out. One wire goes all the way here. Goes all the way to like one of those winch contactors. That's like going to one relay, and the other relay is going to the other one. So it's either like, say here we have wires like, say, orange, purple and orange. So purple, say, is forward, orange is reversed, for example, right? And yes, you can probably notice these are winch contactors. That actually does the forward reversing for like the actual, like the heavy motors. This is all like, you know, like crimped and everything. And notice one thing though, I added these contactors that actually wire up, that actually works together with these guys. So basically these coils are, like, you can say, in parallel, kind of, you can say. So basically what it is, like, and the way this is wired is like, when like, say, forward coil turns on, this turns on at the same time. Reverse turns on, that turns on. Reason for that is because winch contactors, when the contactors are at rest, they it's a short stud or shunts the motors out. So it's like a safety feature for a winch. Like when a winch stops working, it just like shorts its motor terminal, so it's just like, you know, like, so the motor can seize faster, so it locks. I don't want this for this toy car, so that's why I had to like wire up these guys. So like the moment like the forward coil turns off, this turns off, and it's just like the motors can like the whole thing could coast down to a stop. It doesn't just like, you know, all of a sudden halt, like it just skids like on gravel or whatever. And the way these work is like, they're going through these diodes here that are like 6 amp 50 PIV diodes, and this is like forward reverse, for example. So when they go forward, current goes that way, goes into goes into like this contactor. When it goes into reverse, current goes this way. And the reason for these diodes is so like current doesn't flow from, like, say, forward to reverse. So like it goes this way, it goes that way, but it can't go this way, it's blocked. And same, it goes that way, it gets blocked. So like when I press forward, it's not gonna try to backfeed me into reverse. And turning on two coils for this isn't a good idea. And these are all the motor wires. This is all 14 gauge high temperature 200 degree silicone wire. I just like, I'll put it under these bus bars. And notice one thing, what I have under these bus bars, I have like some kind of like a mica like sheet or something. It's like a high temperature piece of like a cardboard, something like they use for like electric heating elements or like inside an electric stove. Reason for this is in case if I have like an arc or something, in case there's a loose connection, something starts getting hot, it's not gonna, like, you know, burn the wood, right? Just in case, even though that can't really happen because it's a low voltage. If this was like, say, 90 volts DC at even 15 amps, then that'd be a dangerous thing. Then you can have like going on, and that's all that can actually, like, you know, turn this whole thing into like toast. I could use this for even like my campfire over there, as you can see. Yes, you can see, folks, this is the perfect place to actually drive this thing. That's why I took it here. So anyway, so what you have here is, this is forward, reverse for left side, forward, reverse for right side. To go forward, you have to press both of these down. To like go make a hard turn, you go this way or like that, or, you know, like that, and so on, right? Like driving a tank. This left and right does nothing, it's just for spare. It's connecting to these two gray wires which are here. I just have them like blanked for now or something. I don't know where they are. Here they are. This one, however, connects an impulse relay for the fans and lights. So the impulse relay is inside this guy. This in this box, you have a relay that's controlled off of that guy, that circuit board. That relay has a capacitor wire to it in parallel. So like when you basically when you pulse it, it doesn't the impulse relay can be very sensitive. So a capacitor acts like a delay, kind of like an electrolytic capacitor wired in parallel with the coil. So when you press it, it turns off after like a couple milliseconds. So it doesn't chatter like the contacts, because the impulse relay is very sensitive. And just to clarify, an impulse relay is a type of relay that when you that has two wires coming out, they're supposed to touch or connect to a momentary normally open push button switch. So basically how it works is you have one pulse turns the relay on, the second pulse turns it off. If you saw my video of my basement automation, you'd probably understand. Yeah, and this is all cleverly designed. So if I have to service one of the motors, I have to take the whole frame apart. And in order to do this, I have to unscrew these. I have to unplug the Molex connectors, such as this one and this one, so I can disable this, because you can see the wiring that's running all along the planks here. It's all not really connecting anywhere. It's only going here pretty much. Along the for the lights, for the cooling fans, the relays for the cooling fans. Only here's all that mumbo jumbo. That's why I have to disconnect it if I have to take this whole thing off to access one of these motors, which is obviously not exactly fun. I had to replace one of the gear motors. I think it was this one. As you can see, this one's different from that one because I fried the gears from because it was I had my younger brother riding it, and when I pressed for hard left turn, one side locked up, it just grinded up the gears. Bear in mind that these are all plastic, they're all plastic gears. Everything is plastic. The only thing that's metal really is the motor itself, the housing, and the little axles or spindles that hold all the gears in place. That's about it. And the screws that hold the whole thing together. That's about it. This is all plastic, so this is just an oversized ride-on toy kind of thing. Really cool, honestly. If you have kids, you can try to put a seat on it and ride it. It's got power. It's pretty impressive, not gonna lie. But this is something I built maybe a couple of years ago. I finally had the opportunity to record it and show it to you guys. And of course I have my street glow. Can't go wrong with LED strip lights. See, so this turns on the lights and the cooling fans. So yeah, what can I say? Nothing obviously I can ride on, especially with my weight. But a pretty cool RC project. I wish it had a longer range, so I can maybe put a camera on it, and I can sit on a computer on my phone and I can watch it drive or something like that. But yeah, it's pretty neat, not gonna lie. It's really it's great for tall grass such as here, not too great for cement or or gravel, right? Because it just becomes a drift machine, because it's all plastic wheels, but they grip well. I drove through even a swamp with it. I drove through a ditch and everything. It's pretty cool. Hopefully you guys like my little setup, and stay tuned for more.